Assalamu alaikum. Just 5 minutes. We will start. We will start after 5 minutes, inshallah. Okay.
Okay, sir.
Okay.
Okay. Assalamu alaikum again. Today, inshallah, we will start a new subject, relational algebra. The chapter speak about relational algebra and relational calculus. We will focus only on relational algebra. Okay, this first thing. Then, inshallah, after finishing the lecture, we will discuss about homework 1 solution, and also we will discuss about this mapping for ship tracking database or ER diagram. We will also discuss about it. Okay, as we mentioned before 2 lectures, relational model depend on relational theory and set theory because we look to the relation as a set of tuples. Actually, this definition for relation get benefits from the algebra about set theory and operation on the set. And actually, we need to focus in this subject because it's very important in database systems. Now we will speak about relational algebra, but later we will see how to use SQL structured query language SQL to execute this expressions or this let us say okay, algebra expression to manipulate the database or retrieve data from database. Okay, so we will speak here first thing about some type of relational algebra we call unary relation. This type of relational algebra operation take one relation and return for as a result part from this relation. When we speak about relation, you have to imagine tables. Okay, we already speak about this before 2 chapters. Relation, and informally it's table, formal name relation. Okay, formal name for rows, tuples. Formal name for columns, attributes. Okay, so you have to put this imagine in your mind when we speak about relational algebra. For unary relational algebra operations, we have input as one relation and output part of this relation depending on the operation. Then we will speak about binary relational algebra operation, which will take two relation and make some connection between these two relation and for example take union or intersect or any other relation. We will speak about all this operations, and the result will be a new relation or a new table informally. Okay, as I mentioned, relational algebra applies some basic set operation for the relational model to retrieve some data, maybe some attributes or some tuples depending on the type of request. We usually call this thing query. Okay, the result of this relational operation, if it's unary or if it's binary, the result will be new relation. This new relation, if we speak about unary, will be part from the input relation, one input relation. If we speak about some binary relation, the input will, the output will be from two or more input relation. Okay. Sometimes we need to apply more than one relational algebra operation. We call this a relational algebra expression. It's contain more than one operation. Like sometimes you need to make selection for some data after make union between two relation or two tables. Okay, what relational algebra operation we will speak about in this class? We have, for the unary, we will speak about sigma, which is select, okay, select some tables from row. We will also speak about the project, which mean we will take some attributes. Here we speak about the rows, okay, or tables. In the projection, we will take some attributes or some columns. And we have also rename. We can make rename for the result or for the relation input to rename it, or even for the attributes. We can also rename the attributes. Okay, we use this symbol for select, okay, sigma symbol for project. We use by for rename, we use row. About binary relational algebra operation, we have union. This comes from set theory. Of course, you already studied it in the university and also in the school. The set theory, we have union, intersection, different or minus, and we have Cartesian product. We have more binary relational operation like join and division. Actually, we will speak about many types of join. If we speak about join, you have actually to focus in the join because it's very important in database. From my experience, we use join too much for retrieving data, because usually you need to retrieve data from more than one table, more than one relation. You need to join between them depending on some criteria. So join, very famous, and also all the versions of the join usually used, not only the normal join operation. So you need to know each type. Okay, about the types, we will speak about outer join, and we will speak about natural join, outer join, and outer join. We have three types. We'll speak about left outer join and right outer join and full outer join. Okay. Also, something that very famous and normal to use in any database systems, aggregate functions or summary functions that give you summary about information like sum, count, average, minimum, maximum. All this operation used too much. About also selection and projection and rename. Also, it's when we speak in SQL, you will see that all queries, it's about select, project, and rename. Okay, this database that we will apply all the examples on it. The company database, I think it's already known from us. Okay, we start first one, select, or it's donated by Sigma. Actually, selection will filter the tuples or give us a set of tuples that based on a condition. Okay, for example, we can retrieve all the students, for example, or PhD students in this course, or we can retrieve all master students in this course. So here we have condition, and we have the selection operation, and we have the relations that we want to retrieve data from it. We will use this database set. In an example, we will use this database set for the company. Okay. Sorry. Okay. Company database. Okay, then in this example, we need to select or get or retrieve. Okay, all this meaning selection. We need to select the employees that working in department 4, department number 4. So we need to get the employees, and we have here the conditions that department number equal 4. So we have segment, we have condition, and we have the relations that we need to retrieve or to get the tuples from it. Also here another example, we need to select employees whose salary is greater than 30,000 USD. So here selection also salary greater than 3,000. So the condition here, it's a Boolean condition. So you can use operation like equal, greater than, less than, greater than, or equal, and less than or equal to for this condition that will be applied on this relation. Okay, of course, when we speak about Boolean expression or conditional expression, the result will be true or false. When the result true for any tuple, then this tuple will be from the result. When the condition false, then we filtered out this tuple. In SQL, we will use where clause. Later, we will see it in SQL. Okay, I think select statement or select operation very common to be used in SQL. Actually, all SQL statement containing select, so it's good to know it. About the properties, first of all, it's commutative. So if you have more than one select, you can use the inner or the outer first. It's same result. So if you have two select, you can apply inner one first, outer one second, or outer one first, inner one second. It's commutative. Another thing, it's take single selection, but you can make it cascaded. You can make more than one selection cascaded with inside each other. The result always will be less than or equal the input relation. Number of tuples. Okay, it's like this. You have relation, tuple, inside this relation, or tuples. This is a relation. You have attributes 1, attributes 2, until attribute n, and we have tuples here. The result will have same attributes, okay, but number of tuples in the result will be less than or equal the input relation. If all tuples apply the condition, then you will take all tuples. If some tuples, then the number of tuples in the result will be less than the input relation. Okay, all queries result will depend on this database state, as I mentioned. Okay, this is about selection. Then selection, we speak about tuples. We retrieve some tuples depending on condition. The tuples that will apply the condition, or the condition in this tuple will be true, will be in the result. The tuples that the condition will not apply on it, or the result will be false, it will be discarded from the result. About the projection or project operation, by operation, it keep certain attributes or certain column from the relation. There is no condition here. You have to give the names of the attributes that you need it in the result. For example, here we make projection for the employee relation. We make project to get only name, first, last name, first name, salary. However, if you look to the database, employee have many attributes. We have first name, mid name, last name, social security number, birth date, many attributes. We only need here 3 attributes. Then we make projection to list specific attributes. So projection create vertical partition from this relation. Vertical partition, columns. Okay. One thing here, when you take columns, sometimes the tables will not be unique. One condition in the database that data in tables cannot be identical for two tuples, because when you speak about set in set theory, you don't have in the same table two set have exactly the same data. So maybe you have data in one attribute like this 25 25, okay, but not the whole tuple.
Please, Doctor,
Not the whole tuple.
I have a question, please, Doctor.
Yes, sure.
Can you repeat the how can we different between Sigma Select and the project? What the difference between them, please, Doctor?
Okay, select, you retrieve tuples. Okay, then you retrieve rows. I need rows that have specific condition. For example, I need rows of the employees that have salary more than 30,000 or more than 40,000. Then you make like this selection and condition salary. Okay, more than 40,000. What's the result here? And you give, of course, the relation name, which is employee here. The result will be the tuples. Then for this one, for example, you will check here. The condition will be checked here. Okay, salary, where's the salary here? Which one salary more than 40,000? This one and this one. Then the whole tuple here, it's in the result. Okay, then the result will be tuples that the condition will be applied on it will be true. Okay, this have true result for this condition, then it's from the result. The result here, employee, for example, and it will have only two tuples, this one and this one. About the projection,
yes.
Projection, you will take specific columns or attributes. So you make projection like this. I need, for example, first name and address of the employee. Then the result will be the column of the first name and the column of the address. Then result here will be also a relation. This relation have two columns or two attributes, first name and address. The data will be all data from here, except if when you have the data, for example, if you have first name X and address Y, and in another part you have also name X and address Y, here you will not have the repeated result. Only one tuple will be in the result. Why? Because here you have key, then you will not have two tuples totally have the same data. But when you make a projection, maybe you did not take the key here. If you did not take the key, then you have possibility that one row will be repeated or one tuple will be repeated. For repeated tuple, you will take only one of the repeated tuple in the result. Hopefully, I answered your question.
Yes, doctor. You are mean. We want to dedicate tuple. We can choose select, but we want to dedicate column. We must be choose project. Is that please? Okay.
Yes.
Many thanks. Many thanks.
Yes. But when you use a project, you
Yes.
have to list the names of the attributes or the columns.
Yes. Yes, doctor. Many thanks.
If you use the project, the result will be columns depending on the name that you select for the column. If you use selection, then you need specific tuples, specific rows that apply Boolean expression or conditional expression. So you need expression here. You need some condition. Okay.
Yes,
Which
doctor.
tuple you need to retrieve. Another thing, when you
يعني
take,
sorry doctor.
okay, go ahead.
Doctor, you mean in select should we contain condition?
Yes, of course.
Mm.
It should contain condition.
Okay.
Project, there is no condition. You just name or list the names of attributes. Another thing in project here, if you have repeated tuples in the result, two tuples have the same data, this repeated data will be discarded. Just you take one from duplicate data. You have to remove any duplication tuples. Okay. Why? Because as I mentioned, the result of the projection will be a set of tuples, and mathematical sets do not allow any duplicate elements. Okay, project not commutative. Why not commutative? Because if you have like this, select or project list, and you have inner also project list 2. Actually, list, okay, list 1 will have to contain all the attribute of list 2, or this operation will be wrong, because and this one will be equal to project list 1, so no meaning here. I will describe this. If you have A, B, C, D, you have this relation with this column's name or this attribute's name. So if you make projection of attributes A, B, and you make projection here, and you have the list, for example, C, D. What is the result here? Actually, there is no result, because you have to make this project first, then Now the result will be for the inner one, C and D. Then you said I need to make another project A and B. There is no A and B here. So list 1 should be part from list 2. And if list 1 part from list 2, the final result will be list 1. So if this one, for example, containing A, B, and D, let me just A, B, and D. This will work. Why? Because the result from the inner one will be A, B, and D, and the final result after applying the outer project will be A and B. So always the final one will be list 1, the outer one. So it's actually equal to project list 1. No need to make inner project. It will not give you any extra thing. So if you have like this inner and outer project, the result always will be the outer one. So it's equal to project list 1. This one, it's equal to this one. Okay. Project inside another project do not have actually any benefit here.
Please, Victor.
Yes.
Can you give us an example about the project that commutative from schema or ER model?
It's
how can we apply that
it's
rule?
not commutative. This mean project list 1 and inside it project list 2 on relation R. It's not equivalent to a project list 2 outside and inside the project list 1. This is the meaning of not commutative. And why it's not commutative? Because if you change list 1 with list 2, list 2 becomes the outer one and list 1 the inner one. It's not equivalent. Why? Because as I mentioned, when you said like this means list 1 should be part from list 2. But if you make the opposite and list 2 outside, this will not work, because if you I give already example, but if I give you the example another time, but in the opposite way. Okay, if we have A, B, C, and D, and we have list 1 like this, projection A and B, and projection A, B, C from this relation. For example, its name R. Okay, this will work, and the final result will be A and B. because after making the inner project, you will have A, B, C. After make the outer one, you will have A and B. The opposite one, it's not commutative because you cannot make this the outer and this one the inner. If you make it, it will, I will write it here. Okay, it will be like this. Project, what's the list 2 here? I will make it outside. It's A, B, and C. And the inner project list 1 now inside, which is A and B. Okay, on relation R. Now, if you apply, you always apply the inner one first. It will give you A and B. Now, if you want to apply the outer one, you don't have C, then this is not correct. So it's not commutative because you cannot change between the inner and the outer selection. Actually, making it cascaded like this, inner and outer, do not have any meaning because outer list will be listed at the end. Okay? Hopefully it's clear for you.
Thank you. It's clear, Doctor. Thank you.
Okay, this result for what we mentioned about the selection and about projection here, project and select, and another project here. All this applied. Please, if you finished asking, you can turn off your mic. Okay, all we applied here in this data. We can see here we need to select the employees, okay, that working in department number 4 and department number 5, and their salary, or department number, here they are working in department number 4 and their salary more than 25,000, or who working in department number 5 and their salary 30,000. This means all the employee in department number 5 with salary more than 30,000 will be in the result, and all employees in department number 4 and their salary more than 25,000 also will be in the result. So we will go and check this one. You remember here, department number 4 and salary more than 25,000. Department number 4, where's department number 4? Here, 1, 2, 3. Salary is not more than, it's not more than this one. So this one will be in the result because it's in department number 4 and salary more than 25,000. Okay. The other part, department number 5 and salary more than 30,000. Where's department number 5 here? Let me just remove this first. Okay. Department number 5, 5, 5, 5. Where's the salary more than? Not this one, not this one. Okay, because we speak about salary more than 30,000. This one, okay. Then the result will be 1, 2, 3 tables. Okay. The employees here, Franklin and Jennifer and Ramesh. Okay, Franklin, Jennifer, and Ramesh here. So we can connect using and, using or, between conditions. Okay, and the result will be also relation here. It's relation, have columns, have tables. This tables will be subset from the original relation tables. Okay, here we are applying for employee to get only the last name, first name, and salary. Here's the result. We get first name, last name, salary. This one from employee also we get the salary, 6 and salary. Here's the 6 and the salary. Okay, this one here, if you can see, this one have project and have select in the same expression. We call this one relational algebra expression. So relational algebra expression, when you have several operation in the same expression. Sometimes you need to get specific tables, but you don't want all the data. You need, for example, only the name and the salary. Here, for example, you need the name and the salary on this condition. So you make selection, then you can make a project outside this select, okay, to get the name and the salary. From where? From the output here. So you can make it, this expression, in single expression, or you can make it like multi operation, each operation in separately. Then you can make intermediate result, then on this result make another operation. This example, here we need to retrieve the first name, last name, and salary of all employees who work in department number 5. So the idea here, I will bring first, let me select another color. First, I need to select employees from department number 5. All employees. Then this one, selection, because I have condition from department number 5. So this first operation, select the employees from department number 5. Then after get the result that this employees from department number 5, I will take only from the result the first name, last name, and salary. This operation, because we need attribute, it's a project. So we make select, then we make project. If we want to put it in single operations, then first one, you need to apply its select to get all employees. So select employees from department number 5. After getting the result, we need to get only first name, last name, and salary. Final result will be all the tables for employees in department number 5, but we get only the first name, last name, and salary from these tables. This first way, single relational algebra expression, if we need to make it as sequence, so we can use this assignment to give name for the intermediate result. So we make selection for employees from department number 5 first, then from this result, department number 5 employees, we make the project to get only first name, last name, and salary. I think we can go here and apply this here. Okay, first thing, we need employees from department number 5. Let me just, okay. Employees from department number 5, then this one, and this one. Okay, this tables will be in the intermediate result. We're speaking here about this one, this way, because in this way the result will be the final relation and enough. Here we have intermediate one, so we have department 5 employees first. The intermediate result will be like this. You have department 5 employees that have all the columns and the selected tables. Okay, never mind, because I stopped here. It will have first name, last name, and
he wants just last name and first name and salary. Just
no, I
three
speak
columns.
about intermediate here. When we make it not single in more than one step. So we have first name, mid name, last name, social security number, person, and all the tables from department number 5. This tables here. This is the intermediate one. Department 5 employees. After that, we make the project to get first name, last name, and salary. So from this result, we make a project to take specific columns. Then the result will be this columns. Like if we have this table, and this one, we will take only the first name, last name, and salary. So the result will be this one. Johan Smith, 30,000. Franklin Wong, 40,000. And Joshua, English,
Joyce,
and Joyce. Okay, 25,000. This is the result. Also, Ramesh Narayan 38,000. This is the result for this final project. This
So,
is the
doctor, I
project.
have a questions.
Okay.
In two ways, we have same result, but which
Yes.
way do you prefer?
Okay. If it's simple
For
like this, let me answer here. If it's simple like this, I prefer to make it one single. But sometimes you have more complicated. We will see later when you use join operation and other operation, and you need to make this operation in specific tables and specific data, not the whole tables. Here you start to have more than 2 operations. Sometimes you have 5, 6 operations in the same expression. In this case, I prefer to make it as sequence because it will be more understandable, okay? More readable.
Okay, doctor.
So if it's simple like this one, it's okay to make it single relational algebra expression. But if it's a more complicated one, it's better to have it as a sequence operation to become more readable. And even it will become better for you to understand if you have any problem in the result, where is the problem and what I missed exactly, where I am wrong in which part exactly. So sequence for more complicated will be best practice actually. Okay,
Okay,
rename or raw. Sometimes in the result we need to rename attributes. Even sometimes we must rename attributes. For example, in some type of join, you don't put condition to join two relation. It will be depend on the name of common attributes. So if no common attributes, you need to rename. This we will see this case later. Okay, so sometimes you need to rename the relation or rename the attributes. That's why in relational algebra here we have operation rename, or it's donated by row. Okay, row you can rename relation or attributes, or both. You can rename relation and attribute. It's as I mentioned, useful in some queries to rename to understand what result you need, especially for aggregation function. For example, if you want to get the summation of the salary, so you need to name it specific meaning that specific names that you need it, or the average of employee salary, or number of employee, or something like this. Then you need to rename it in some cases. Some cases it's necessary, as I mentioned, especially in one type of join operation, it's necessary to rename. Not all the join operation. There is one type of the join operations that it's necessary to rename the input. Okay. How it's work? It's work like this. You have three form for rename, and the new name for the relation and the new name for the attributes. And this is the input. Input will be relation. The result will be new relations that have new name and have new attributes name. Actually, for all most operation, you will keep the name of the input relation. Here for the selection, if you see here, okay, in the selection and in the projection, we keep the names as it from the input relation. If you check in the employee and if you check the result here, it will have the same names. But if you make rename, then the output will have new name. Here in this case, you rename the relation itself and the attributes. Sometimes you need to rename only the relation, so you can only make rename for the relation or only rename for the attributes. Okay, here example for rename. Same example we take before, that we get employee from department number 5 and we get only first name, last name and salary from this employees. Now we can rename this in two ways. First way, we can make it like this. Instead of writing result only, we can give attribute name. Here without row. Without using row. Sorry, row. This one without using row, directly the result, and you give name for the attribute. First name will become last name. Sorry, F name will become first name. L name will become last name. Salary, you give salary. Because we have three attributes, this one same, but with rename. Instead of result, we name the output relation R and we give attributes name. Because we have three attributes here, so we give three names here. So the output here and here will be similar. The only difference that the attributes name will be different. We can, I think I have this one. Okay, then this one we have the first way, this one, without rename. It will take from the employees the names, F name, L name, salary. This is the second way. We have here, we have here temp as selection. You look before the rename, it's same name as employee, F name, middle name, last name. After making this operation, we have a new relation R that have only first name, last name, salary. So we have R, the name of the relation. We give the name of the relation here, which are first name, last name, and salary. You look to the result here in A and result here. The result here take the name of the attribute from the original employee relation. The result here, we rename the attributes name to the first name, last name, and salary without using row. Or we can rename any relation with using row like this. For example, department 5 employees, we rename the attributes to F. So if here there's some missing. Okay, it should be like this, comma. FL, this means first attribute here in department 5 become F. Second attribute name become M. Third attribute and even department 5 name become result. So we change here the name and the attributes name. Okay, union. I think we can take, I want to ask you before taking a break. Do you have a lecture after this one?
No, doctor, we haven't.
No.
Yes,
Don't have.
we have.
Anyone have lecture? Just write
Yes, sir.
if you have lecture. What time you have lecture? Noha, do you have? I could not.
Yes, sir, I have, but after 1 hour.
It's okay if after 1 hour.
Yeah.
So we take a break 5 minutes, then we continue, okay?
Oh, okay, doctor.
Because I will
Okay.
take more time.
Okay, doctor.
Okay, just 5 minutes.
Okay. So.
Okay, السلام عليكم.
وعليكم السلام ورحمة الله دكتور.
عليكم السلام دكتور.
Okay, we continue here. Relational algebra operation from set theory. We have the union, intersect, and different set different or minus, and I think also we have Cartesian product. Okay. It should be familiar for you, the union. In the union, we will, the result will include, of course, union, it's binary operations. So we have two relation as input. Between these two relation, we will make union operation, and we have result, for example, a relation T. Okay, this relation T as result will include all tuples that are either in R or in S. So both R and S will be inside T. But we have here some criteria that R and S must be type compatible. Type compatible. Why? Because the result here will take tuples from R and tuples from S. So all the tuples will be inside T, inside the result. So the attributes for the tuples should be from the same type, because at the end, the attributes of T, like this, or the columns, and the tuples will be part from R, part from S. So R and S should have the same type of attributes, same number of attributes, or same column number, and corresponding attributes, attribute 1 here, attribute 1 here, attribute 2 here, attribute 2 here, attribute 3 here, attribute 3 here, should be also from the same domain. Domain compatible, or the attribute, the buyer attribute will be compatible. So it's usually like this. Sometimes you said, I need the employees from department number 5 and employees from, for example, that have salary more than 50,000. So you need the result to be in one relation. The result from the first operation, employees, and the result from the second operation, employees. So they are compatible. So you can make union between the two results. In this example, we want to retrieve the social security number, SSN, of all employees who either here give you ideas that we need to make union. This keyword either, okay? Who either work in department 5 or either or, of course, either or or directly supervise an employee who works on Department 5. So, first part, we need to get employees from Department 5. Department 5 employees. Second part, we need to get employees that directly supervise employee who works on Department 5. So we need to get the supervisor employee for Department 5. Then we will make union between the two results. After make union, we don't need all the data. We need only the social security number. You can take the social security number first for each part, then make the union, or you can make the union and then make a project to SSN. Okay, then this plan to answer this question or this example. So at the beginning, we retrieve employees that belong to Department 5. Then we have here employees from Department 5. Then we make a project to get only the SSN for these employees. So first result will be SSN, social security number, for employees only of Department 5. Okay. Another part, we need employees who directly supervise an employee who works in Department 5. So we have Department 5 employees. We will get the super SSN. What is the super SSN? If you look here, here you have the social security number of the employee, and we have super SSN. It's the supervisor of the employee. So we get the employees from Department 5. Then we get the super SSN for this employees. What this mean? This the supervisors of the employees, supervisors of the employees in Department number 5. You will see it here. The employee itself, here's the supervisor for it. Okay, then we have employees from Department 5, and here the super SSN, and we rename it to SSN. So the result here, the supervisor's employee for Department number 5, and we rename the result because the result super SSN, but we rename it to SSN. Now we just make the union between result 1 and result 2. Result 1 and result 2. So the result will be tuples that either in result 1, which is here, and or from result 2, or both. We can see here result 1 which have all the employees from department 5. Result 2, which have all the supervisors that supervise employees from department 5, and the final result will be the union. You can see here, focus. This number come from here. This number exists here and here. When you make union, as I mentioned, the result will be relation, and the relation have set of tuples, and mathematical set do not have duplicate data. So you have here, if you make union, you will have 1, 2, 3, 4, 5, 6 tuples, but here we have 1, 2, 3, 4, 5. Why? Because this tuple duplicated here. So you take only one copy from duplicate tuples. So we take all SSN from here first. Then we start to take this one. This one already exists, so we don't need to take it. This one not exists, so we take it in the union. Okay. Type compatibility, actually, it's should be in the union and intersect and set different. Because the result will be between this set or tuples, so tuples should be compatible to get the result. Okay, about intersect. Intersect here, we will have all tuples that in both R and S. Sometimes R and S, of course, R and S will have same attributes, but could be not the same name. Attributes should be compatible. This means number of attributes. If this one have 5 attributes, this one should have 5 attributes. And attribute 1 here should be same domain, like attribute 1 here. Attribute 2 here should be same domain like attribute 2 here, but could be different name. Here could be SSN, and this one, for example, ESSN. But they are type compatible, so it will work. Okay, what about the result? The result, which name will take? The attribute name, this one or this one? It always will take the name from the first relation. So if you have 2 relations with different attribute name, and I mean the buyer of attribute, first attribute here, first attribute here, or third, for example, in the first one, and third in the second relation, have different names, always the result will be same as the first relation, for example, R. And they must be type compatible. As I mentioned before many times, it should be type compatible, but it could have different name. If different name for attributes, then the result will have the attributes name from the first relation in the operation. Okay, set different or minus. Set different actually will have all tuples from R, for example, if we have R minus S, the result will have all tuples from R that is not in S. It's like any minus in the math. Here you are minusing the tuples. So if you have tuples in R and tuples in S that have the same values, this means if you make minus, you will have the result as all tuples from R except the tuples that already exist in S. Okay. Then all tuples that are in R but not in S. This is the result. Any tuple that repeated between R and S will be discarded from the result, or will be ignored from the result. And what about attributes name? Attributes name also will be from the first relation. Also should be or must be type compatible. Okay, this examples. If we have instructor and students, and this two type compatible, we have F name here, L name here for student, and we have F name, L name. You look here, attributes have different name, but the domain for Fn here and first name here should be from the same domain. This we called it type compatible. Ln here and last name here from the first domain. So this two type compatible relation or compatible relations. Okay, first thing we need to make union. In the union, you will have in the result, here's the union. This one intersect, this one minus or different, and this one another minus. This minus between student and instructor. This one minus between instructor and the student. Of course, there's big difference because you will take tuples from the first side and you will remove any tuples that exist same in the second side. This is the different or the minus. Okay, about the union, we take all the tuples from first side in the union. You can see here, same tuples. Then we take the tuples from the second relation, except if there is repeated tuples. So you will remove the duplicate here. So Johan, we take it, reach you. If you look to Susan here, you will find it here. So you don't need it in the result because it's duplicate data. Okay, Francis, okay. What about Ramesh? Ramesh here, if you look, it's also in the student. So no need to have it again in the result. Okay, intersect. Intersect, you need the tuples that in the same side, the first side, and at the same in the second relation, or repeated tuples in both relation. We have this one, Suzanne, Ramesh, Suzanne, Ramesh. Then this is the result. About different or difference or minus, you need tuples in student for this one, student minus instructor. So tuples from students and any tuple that repeated in instructor will not be in the result. This is the difference, or students minus instructor. So this one and this one also in the instructor. So we don't need it in the results. So we have Johan, Barbara, and so on. Okay, where? Okay, let me just clear the screen. Now, what about the opposite? If we need instructor minus student, so we will take all the instructor except the repeated tuples in the student, which is Suzanne and Ramesh will not be in the results. So we will take Johan and Ricardo and Francis. I think it's simple and clear here. What about the properties? Actually, union and intersect are commutative, but minus or different, not commutative. And we can see it very clear from this example, because the result for student minus instructor, it's not the same as instructor minus student. So it's not commutative. R minus S, it's not similar like S minus R. But about the union and intersect, it's commutative. R union S, it's similar like S union R. R intersect with S, it's similar like S intersect with R. Only there is one different. What's the different will be? Here it's commutative, but the result will have only one different. What is the different? Could have, okay? Could have different, the result. Anyone know? Okay, I will give you the answer. The result could have different names for the attributes, because if you have two relations, R and S, for example, relation R have names for the attributes A, B, or A1, A2, A3, and S have names, for example, B1, B2, B3, but they are type compatible, okay? These two relations type compatible, so you can make a union or intersect. The result for R R union S will have all the tuples from R and S, but the names of the attribute will be taken from R, from the first side. So it will be taken from R. So it will have names for the attribute A1, A2, A3. But the result of S union R, also it will have all the tuples from S and R. So it has same result. That's why we said commutative. But the only difference here, the name of the attributes will be taken from S, because S here becomes a first side. So the name of names of the attributes will be in the result B1, B2, B3. Okay? I think it's clear what I mean here. It's commutative. The only difference in the result will be the attribute's name. But the data inside it, here, the tuples will be same. And because we speak about set operation here, so we speak about the set here, not the attribute's name. That's why we said it's commutative, because same sets. And set always, you don't care about the order. So if you put tuples of R first or tuple of S first, doesn't matter, it will be same. So the result here and the result here will be equal, depending on mathematical set. Hopefully it's clear. Okay, what about Cartesian product? Cartesian product, I think we already spoke about Cartesian product before, or it's a cross. Here in Cartesian product, the result will be a new relation that have attributes, okay, of relation R and relation S. So the relation, the result, for example, Q will be from degree n plus m. If this relation have n attribute and this relation have m attribute, the result will be will have n plus m attribute. We will see examples to see what the result, okay? Here is the idea. The two relations that you want to make Cartesian product between them, for example, R Cartesian product with S, it's not necessary to be type compatible. Do not have to be type compatible. Actually, let me go directly to the example. Okay, I think the example will be later a little bit. Okay, actually Cartesian product for set means you take each tuple from R with all tuples from S. So each tuple from R will be taken with all tuples from S. This is a Cartesian product. Because if you have two sets like this, and you want to make Cartesian product, if this set you have A and B, and this set have C and D, and you make Cartesian product, the product will be or the result will be A, C, and A, D, and B, C, and B, D. Okay. Then I want to ask you, what's the number of attributes and what's the number of tuples? Number of tuples, okay, will be or will depend on the Cartesian product here. Each, where is the example? Okay, actually it will be number of tuples here with number of tuples here. It's multiplied. Okay, 2 by 2, it's 4. But number of attributes will be 2 plus 2. Then number of attributes will be n plus m, but number of tuples will be n multiplied by m. Okay, we will take example here. Then the new relation Q will have like this. A1, A2, what's this? A2 until AN. This comes from R. And B1, B2 until Pm. This comes from S. If we make Cartesian product, if we say the Q equal R Cartesian product with S. About the tuples, each tuple here in R will be repeated with all tuples of S. That's why number of tuples here will be n multiplied by m. Okay. Actually, the problem with Cartesian product itself do not have a meaningful result. For example, here we get female employees, okay, in this example, and we get the first name, last name, social security number of female employees. Then we make Cartesian product between this female employees and dependent. What this mean? This mean if we have employees, for example, X and Y, and we have dependent A, B, C, then you are making Cartesian products. This means X, A will be in the result, X, B will be in the result, X, C, also Y, A, Y, B, Y, C. If A even not dependent for X, it will be in the result. Here, it's like you said, X employee have dependent A, but actually it could not be the situation. So you mixed here or combine between tuples even if there is no relation between this tuple. So the result will contain every combination of employee and dependent, whether or not they are actually related. It's like you give son of some employee to another employee. To make it meaningful, you don't need to take all the result. You need to take when this employee actually father or mother for this dependent. So to make this meaningful, we have same example, but we add this one. We add select when the social security number of this employee, okay, same as social security number of the parent of this dependent. So we make mix between them, then we make like a selection or filter for the data to get the actual or the needed data. I think, okay, here will be clear. This is the result for female employees. This result. Let me name them. Female employee. Okay, this one employee names or just the female employee. Okay, this is a female employee. Female employee. Okay. And then we make selection for project, sorry, for first name, last name, social security number for female employees. Then here we take from the female employees, we take first name, last name, and social security number. Then this is the result here. Okay, this is the dependent relation as it. Now we make Cartesian product. Here, Cartesian product between dependent and between the female employee. Cartesian product between this one and this one. What's the result? The result, we will take each tuple from here with all tuples from here. Second tuple with all tuples. Third tuple with all tuples. Then the new relation will have like this. You can see here. You can see here. Each tuple, this tuple comes from employee with all tuples from dependent. It's repeated here. The tuple of employee repeated with all tuples from dependent. You can see here dependent 1, 2, 3, 4, 5, 6, 7. Okay, repeated with the first employee. Then 1, 2, 3, 4, 5, 6, 7. Repeated with employee 1. Repeated with employee 2. Repeated with employee 3. Then we have 3 multiplied by 7 as number of tuples, which is 21. And how many attributes will be 1, 2, 3, 4, 5, 6, 7, 8, which is 3 from employee plus 5 from dependent. Okay. So we have 20 for first employee, for second employee also, and for third employee, the total will be 21 double. Okay, until now, this do not have any meaning because if you look here, until now it's not meaningful because we make Cartesian product between tuples that not related actually. It's not related. Here, this employee, father or mother for this dependent, depending on social security number, is different. So this one belong to different employee, but here I put this dependent for this employee. So Alisa, for example, it's actually not father or mother for any of this dependent. Here, Jennifer, this one dependent belong to Jennifer. And for Joy, I think no one, only this one belong to female. So to make or to get the actual result that we need to check the social security number of the employee that depend or this dependent belong to it with the social security number of the female employee. If it's equal, then this dependent belong to this employee. This is the actual dependent. Now it's become meaningful. Then I can make the projection if I need only the first name, last name, and dependent name. So about the result for actual dependent, it will be like this. Only Jennifer, because it's the only one that its social security number equal to social security number of the father or mother of this dependent. Then we make a projection or project to get only the first name, last name, and dependent name. Okay, this example. About the join, it's very important to take the join. Let me check how many slides. Okay, we still have too many slides. Okay. I need extra time, so so it's better to have one more lecture this week to complete the chapter and also to discuss the previous homework and exercise. So what about meeting another time today? Maybe after 7, after 6, like this.
It's okay
It's,
for me.
I have business please, doctor. I contact with something business, so I can't free today. And tomorrow I have two lectures. And after that, we have one lecture and a meeting with the supervisor about our thesis.
Okay, then you will you have work until midnight or something like this. We need another 1 hour or something like this today. Maybe we can meet again at 9 p.m. or 8 p.m. today. Do you have meeting at 8 p.m. Muhammad Yusuf?
8, doctor, or 9?
8 or 9?
Okay, no problem. 8 or 9, no problem.
So we meet again to.
Okay.
So we meet again to
Actually,
continue.
doctor, I have work.
What you have?
I have work.
Okay. So, okay, I will give you another appointment on.
What do you think about tomorrow, doctor? 9 p.m.
Do you have Ahmad work also tomorrow?
Tonight? Tomorrow?
You said
No,
tonight
tomorrow.
you have tomorrow.
At 9 p.m.
At 9 p.m. I don't know, doctor.
Then we meet inshallah tomorrow at 9 p.m. Okay?
Doctor,
Okay, doctor.
if I have a question about second homework, will I ask now or you cannot ask?
What about second homework? Actually, I will give you more time. Okay, thank you. You remind me for one important thing. Your exam will be on 12th of April. Your midterm exam will be on 12th of April. So the midterm exam will be like this. We will take the midterm exam using OYS system. Okay, but there is some questions that you need to write on papers. For example, some questions about ER diagram, you need to draw it on paper, or if we have a question about the relational model, you need to draw it also on paper. After drawing on paper, you need to scan and send within 10 minutes.
Doctor,
Okay.
the time duration for exam, how many times, please?
It will be around 1 hour.
Doctor, 1 hour is too short.
It's
Yes.
I know
enough.
it will be enough. Don't worry.
It's
It will
not
be
enough,
enough.
Doctor, and how many questions?
We cannot get the excellence answers. It's when can you use it when 30 hours?
I will see. It's depend on the questions. It will be enough. Don't worry.
Thank you.
It will be more than enough depending on the question.
All the questions.
I can make it 1.5 hours depending on the question.
Doctor, is if the all questions will be written by paper?
No. Only if we need to draw something.
Oh yes.
Okay.
If there are
there's another important thing. There is another important thing.
Yes.
You have to be ready that during the exam, you have to be in front of the camera. So you need to open the camera using
No problem. No problem.
a team. Okay.
No
No.
problem.
And,
Doctor.
Oh,
No
no
problem.
problem.
and
That's
you will upload your file during this. During the exam, I will give you after in the exam around 10 minutes to upload any extra handwriting. Okay.
Okay.
Most the question will be directly online, like multiple choice, or maybe I did not put the question yet. After I put the question, I will
How
give
many
you
questions?
idea about the type of the questions.
How many
But to
questions?
prepare
3 or 4?
yourself, okay,
okay.
Yes.
I will give you like this. I will extend the homework submission. You try to answer the homework on paper, the current homework mapping, okay?
Yes.
Scan it, handwriting, scan it and upload it, like a training for you for the midterm exam, okay?
Yes, no problem, Doctor. How many, please, Doctor, how many questions will be are there? 3 or 4 or more?
I'm not sure yet. I told you maybe next week, after I put the exam next week, we will discuss about the exam.
Doctor,
Okay?
can you give us a pre-test for the midterm, please, Doctor?
Sorry?
Can you give us a pre-test for as a preparation for the midterm to experience about the midterm, please, Doctor?
Okay, I already give you 2 homeworks. It's important to understand the homeworks.
Okay.
Other questions we will discuss later about the type of the question next week, inshallah.
Okay, inshallah, Doctor.
Doctor, what about the point of the midterm exam?
Okay, this is another issue. I will speak about it.
And the homework.
Okay, let me mention it. We will. I will put 30%. 30%. Okay. For the midterm, and 10% from the 2 homeworks. I will open homework one again for 1 day, but this time you need to answer a new question for homework 1 if you did not upload it. This is another opportunity for students that they did not submit homework 1. I will put another question and give opportunity for them. Okay?
Okay.
Homework 2, I will extend for few days.
Yes.
Very good, Doctor.
Thank you,
Thank you.
Okay?
Doctor,
So
please,
you have 5 marks for homework 1 and 5 marks for homework 2 and 30 marks for the midterm exam.
I have final question, please, Doctor. If you
Go
mind.
ahead.
If there are any project in the for the final for this class, Doctor?
We have a presentation.
Okay.
Presentation. Maybe during 2 weeks I will give you the. I will distribute the names of subject for each one of you.
Is that the presentation individual or team, group by group?
No. Each one separately, individual.
Okay. Many thanks.
I will make as much subject as different. You need to write, for example, 10 paper, okay? Or I mean, you can send me PDF that have 10 pages, and you will make presentation for around 10 to 15 minutes. This
the topics. Who will choose the topics about what?
I will give you topics name, and during maybe after the midterm exam, you can start selecting during one of our lecture. I will distribute to have balance. Okay, I don't need all students to have one topic and some topics not having student. So to have balance, we can discuss in one of our lecture later. Okay.
Many thanks, Doctor. That's clear.
Okay. I think that's all for today. We meet tomorrow 9 p.m. inshallah.
Inshallah.
Excuse me, Doctor, you have time?
Yes, if any of you have another lecture or have some work, he can leave. And if one of you have a question, I can answer, but please make it short, okay?
Okay, Doctor, about